Okay, so we're talking about chance experiments and events for probability. And so the first thing that you need to know about probability is that you're looking at the likelihood or the frequency of something happening over an entire sample space. And so we're going to look at creating some sample spaces and how do we kind of interpret different events that could happen from that. Um, so this scenario here, we are looking at results of 2 consecutive golf games. So the first game you can either win, tie, or lose, and the second game you can also win, tie, or lose. And so we want to know all of the possibilities that can happen in order to figure out down the line what the probability of one particular event would be. So for your first game, you can win, you can tie, or you can lose. And for your second game, you can win, you can tie, or you can lose. So we have 3 possibilities for each game. So we're going to end up with 9 total possibilities because each of these will multiply by the other 3 times to create our sample space. So the way we would look at this is that like S equals, um, and then we're going to write all our possibilities. So we've got the win first. So we've got a win and a win. And we're going to have a win and a tie. We're going to have a win and a loss. And then we look at ties first. So we got tie and a win, tie and a tie, and a tie and a loss. And then finally the loss first. So it would be a loss and a win, a loss and a tie, and 2 consecutive losses. So now we can use this to figure out different probabilities or different events that could occur. So what about the events that we lose? So the chance that we were to lose a match. So any loss. So this is an event. So that consists of, see, our win and loss, our tie and loss, our loss win, our loss tie, and our double loss. So the chance or the number of events, single events, where we have a loss is 5, right? There's 5 different ways for that for us to lose at least one game. And we could figure out all sorts of different events from this, ones that intersect with others, but just creating a sample space is the key to first understanding how to do probability. Now let's look at the next one. Okay, so an observer will stand at the bottom of a freeway off-ramp and record the turning direction of each of 3 straight vehicles. So the sample space consists of 8 outcomes. So we'll see how those outcomes come about. So the first car can either turn left or right. The second car can either turn left or right, and the third car can either turn left or right. So each option we could go in 2 different ways. So we start off, let's say we pick L. Well, L could, or our left car could be followed by a car turning right or left. And from each of those, we have 2 different options. So for each car, we've got 4 total routes that we could make, if you can see that. So we've got our sample space. Is we can have left, left, followed by another left, or a right, left, left, right. So we can have left, right, followed by a left, or right. When we move to the right car, we can have a right, left, to a left, or to a right. And finally, we can do a right to a right, goes to a left or a right. Okay, so you could make a probability tree from this, and it would look something like this. So we got our first car. We can go left or right. And from each of those, we could go left or right. And this is our second car. And then from each of those, we could go left or right again. So if you looked at these events from the side of a probability tree, this would be LLL, this is LLR, this is LRL, this is LRR, RLL, RLR, RRL, and RRR. So you can quickly see that there's only one event that doesn't have a right in it, and there's only one event that doesn't have an L, and the rest are mixtures of the two. So you constructing a tree or constructing just a sample space in general is a skill that you need to know how to do. And the last question we're looking at, the instructor in a seminar class consisting of 4 students has an unusual way of asking questions. So 4 slips of paper are numbered 1 through 4 and placed in the box. The instructor determines the student to whom any particular question is to be addressed by selecting one of the 4 slips. Suppose that one question is to be posed during each of the next 2 class meetings. So one possible outcome could be represented as 3, 1. The first question is addressed to student 3, and the second question is to student 1. There are 15 other possibilities. Consider the following events. So let's look at our sample space first. So we've got, we've got class 1 and class 2. We've got 4 possibilities for each. We've got 1, 2, 3, or 4. 1, 2, 3, or 4. And so for each of these, we can create a sample space, just like we have before. So we could consider, what if the first person, or the first day, we have a pick of the first person. So we're going to have 1, 1, 1, 2, 1, 3, and 1, 4. And then the second day, and so on and so forth, we look at every possible outcome. So we've got 2, 1, 2, 1, 2, 2, 2, 3, 2, 4. We move on to set 3. So we got 3, 1, 3, 2, 3, 3, 3, 4. And finally, what if the fourth person goes? So we got 4, 1, 4, 2, 4, 3, and 4, 4. So you should see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possibilities. And that comes because we have 2 independent events, and we'll talk about this later, where we have 4 options each. Now, once you have these events, it's important. Once you have the sample space listed, you can create all sorts of other different events, and you can look at unions and intersections and everything. But it all comes down to knowing your sample space at first. So make sure that you're able to create that, and then from that we can go ahead and find our probabilities later on.